me today is Matt with Magestic Technologies. He's our subject matter expert, and he will be presenting today and over the course of the next 3 webinars. Again, I want to thank you all for being patient today. And again, sorry about the little bit of a technical difficulties. Hopefully we'll iron things out on our next go around. But Matt, you can go ahead and take on the show. Well, maybe I should just quickly jump in here for a second. Sorry about that. As I said, my name is Robert Picinic from SolidCAD. Been with SolidCAD now for over 13 years, reaching 14 years very soon. I'm in the advanced manufacturing team. We sell products like TruNest and many other products here at Autodesk that has Power Shape, Power Mill, Feature Cam, all the Autodesk CAM products. And like I said, TruNest is one of our products as well that we work with Magestic on this. So Matt, can you put on the next slide for a second? I just want to talk a little bit about SolidCAD quickly. Thank you. So, you know, our focus is really to help our clients to implement the technology and basically to optimize all your workflows with the Autodesk portfolio. Next, please. Next slide, please, Matt. Thank you. We have offices across Canada. Our training facilities are in most of the main hubs. You can see them listed here. Thank you. Next slide. Thank you. And as far as the training options you have, we have some open enrollments for our standard classes, and most of the custom training that we do are on the higher end advanced manufacturing tools like TruNest and the other products I had listed earlier. Thank you. Next slide. Thank you. Next slide. All right, and back this year in May, amongst all this COVID-19 this year, SolidCAD and Magestic announced a very important partnership on consulting and the training and then implementation and supporting our Canadian manufacturing firms with the TruNest product. And through Magestic, they also have, including the TruNest, their True Composites, as well as the other nesting tools that they have as well, and helping our customers as well as their customers optimize their workflow. Next slide. I think we're going to start.
I think that brings it to me.
Right, now it's your turn, Matt. Thank you very much.
No problem. Thanks, Rob. So my name is Matt Thorn. I'm a senior manager here at Magestic Technologies, focused on product and customer success. And I'll be taking you through the webinar today. As we put in our agenda, we're going to be discussing TruNest and looking at digital workflows for how we optimize materials, integrate with ERP and MRP systems. We're going to show off our interface to Inventor and to Vault, leveraging the PLM lifecycle as well as material and inventory management. And specifically on the cutting side, we're going to be looking at laser sheet metal fabrication today. So some optimizations around common line cutting, fly cutting, etching, tabbing, and touching on some of the nesting algorithms as well. I just wanted to give a brief overview about TruNest and Magestic Technologies. So TruNest has been available since 1991, and it is an advanced nesting and manufacturing software covering industries in transportation, aerospace, construction, and power generation. And our specialty here with TruNest is really integration and automation. We provide a very robust platform in order to allow users to customize workflows and really bring in data from all systems through the entire design and manufacturing workflow. So some of that includes the materials that we manufacture from. So we're looking at materials like metal, wood, composites, leather, also grating, honeycomb core, plastic, foam materials, any kind of bar extrusions, thick or thin. It really doesn't matter whether you're doing light gauge, stainless, or thick gauge materials. We can optimize the program for each of those processes and the machine tools that run them. For example, in general, we can program for contour cutting machines as well as multi-tool cutting processing machines. So for contour cutting, we have lasers, water jets, plasmas, oxyfuels, multi-tool cutting, punch press routers, combination of those, punch laser, punch routers. We write all of our own post-processors for TruNest at Magestic Technology, so we can support whatever machine that you're running there. So in general, TruNest as a workflow is really at the center of the design to manufacturing process. So first off, we have the design integration into TruNest. So whether that's native CAD data like AutoCAD or Inventor, or whether it's generic CAD data like DXF files or DWGs, or if it's even legacy NC data, we can bring those all into TruNest via our any CAD translation options within the software. We can even integrate with PLM and PDM systems like Vault or others if you have something outside of the Autodesk portfolio, and bring them directly into TruNest. So we take that design, we bring it into TruNest, and we get that to the shop floor as quickly as possible. So we can run all your different machines, whether you have lasers or punch presses, plasmas, water jets. And we do that by integrating both orders and inventory within the system in order to drive production on the shop floor. So all the while we're generating things like reports, outputs, to sync back into whether you have an MRP or ERP system, whether you have shop travelers on the floor, whatever reporting mechanisms that you're using. You can go through this entire process. At a higher level, TruNest does connect to a database architecture. So when you start to get into things like ERP and MRP, we can directly integrate those things and start to drive your sales orders through the inputs to TruNest, your inventory tracking from the shop floor, and managing what's consumed and what's remnants and things like that throughout the entire system. So with that, I'd like to take you through TruNest and show off some of the functionality within the product. So let me switch over here. Just give me 1 second. Okay. So as I bring up TruNest here, the first thing that we come to is an authentication screen. So TruNest requires you to log in with a username and password. And the reason for that is we like to track and have some traceability over what users are doing within the software, so we can understand what orders are being created by what users, what parts are being brought into the system, as well as we apply certain workflows to certain user levels. So as an administrator, which is what I'll log in as here, I'll get full access to all the different workflows within TruNest by default. So as I log in, it's going to ask me which workflow I want to log into. So whether that's some of the defaults here between admin, engineering, or shop floor, I'm going to click on the admin one and log in, and we'll see TruNest come up. So that workflow is represented by the functions that I have up here inside of the ribbon. So I have all these different tasks and options up here that I can choose to do, as well as the options that I have here on the left-hand side in what we call the tree. So if I wanted to see some of the workflows that are preset within the software, I can switch on the fly since I belong to these groups as well, to an engineering group. And if I hit OK, you'll see that tree and that ribbon update on the fly. So now I'm looking at the workflow that's specifically for an engineer, which may be maintaining material databases so that design and manufacturing are synced between that information, and bringing in part geometry as well, making sure that all the designs are prepped and ready for manufacturing. So all that information within the software is kind of tailored for that engineering role. And then more downstream tasks, if we go over and switch to the shop floor, we can see things like orders and nests and being able to create nests and generate NC code and send that down to the machine tool. So those workflows are already tailored and set up within the software, but it also lets you customize any potential workflows that you might see in the future. If you want someone to be the capacity planner or a business administrator and really dictate which orders are going to which machine tools and things like that, you can customize that workflow how you see fit and create these groups on your own on the fly. So let's switch back to an admin group. So we'll see the tree here is going to be my main source of getting to what we call each one of these workspaces. So really there's 3 steps within TruNest in a basic workflow. So we have to bring geometry in, and again, any of those sources I mentioned before, whether it's from Vault or Inventor or AutoCAD files, generic CAD data or legacy NC files, or to bring those into TruNest so it has a record of those. Then I want to process my orders. So I want to bring parts together on like materials, schedule them for certain due dates, and bring in certain information on those as well. And then I generate my nests. So I send them, generate the NC code, and I send them to the shop. So we'll start on our first point in the workflow here with the part import. There's a couple different ways that I can get parts into the system. The first one of them being parametrics. So there's just some basic parametrics within TruNest that allows you to create parts on the fly. So whether you're looking at things like creating a square or circle or rectangle, some basic shapes, you can just input some basic parameters here about what that geometry is, and you can generate those shapes on the fly. So that'll save you some time from the design work. If you needed some parts quickly. The next process is what we call translate. So a translate is a geometry translation. So it translates your CAD files into what we call an MSI format, which stores all the information that we need about that design and manufacturing data from that CAD file. So that's just a raw geometry translation. So any metadata like material information isn't brought in that step. That step is done through our automat option. So with our automat option, we can both translate geometry and metadata information in that CAD file. So if I'm working with Inventor data, since we have that integration with TruNest, I can access things like the bill of materials and find out what materials that I'm using for each one of those parts, what the thicknesses are, what the assembly, sub-assembly structure is, any other specific or custom eye properties or information that I want to pull out of that model. I can gain access to that with an automatic translation option. And the one that I want to look at today is our Vault option. So the Vault option goes a step further, and instead of you having to select a file that's somewhere on your disk, you can actually just query Vault and say, hey, Vault, get me that file that I'm looking for, and do that automatic translation process that I talked about for me automatically. So I've got my Inventor part up here. So this is the part that I'm looking at within my sample today. So I've got this up. It's currently checked into Vault, so it's sitting there waiting for me. So I'll go ahead and reference that inside of my Vault. So this assembly is called just a PC chassis. So I'll just type that in here. This is the part that I want to find within my Vault, and all I have to do is click download Vault parts. What it's going to ask me to do is it's going to ask me to log in with my Vault credentials, just like a normal Vault application would. I can pick the server and the Vault that I'm looking for, give it my credentials, and as long as I get in, it's going to start searching and downloading all the relevant information about that assembly. It's also going to give me an update on whether or not I found that particular assembly, if there was any issues, if there was a particular state that that part was in, like if it was currently in work in progress and not released to manufacturing. We could show those things up in this result and let you know what the status of each individual component is. So I'll click OK, and it's going to run into this translation process that I mentioned before. It's going to extract all those parts from that assembly automatically based on that bill of materials, all the material information, everything that I want inside of that assembly. Specifically in this case, we are after the sheet metal components. Since we're using the sheet metal fabrication for a laser machine, we are setting the flag within this translation process to skip any kind of standard screws or bolts or things like that, and really just investigate the sheet metal components. So it'll automatically filter those components that you don't want in that assembly, and then you don't want to drive with TruNest out of the model and bring in the stuff that you do want to. So we can see here that I have the parts. I'm bringing in bend line information as well as this metadata. So you can kind of see, you can see right here in the middle of the part the information about what the assembly is, what the individual part name is, what material it was, as well as the thickness. You can also see different colors on the shape. What it's doing during this translation process is it's automatically coloring geometry based on quality settings for the laser. So if I've got really small shapes and things like that that I want to have a fine accuracy on, TruNest will automatically colorize those shapes so that the quality of the laser is represented for those small shapes based on your tooling requirements. So in this case, it's using a medium quality for some of these internal shapes and a lesser quality towards the outside periphery. So you can kind of go through and see all the different components that was brought into my assembly, all the different bend line information, and the metadata that was here, and make sure everything looks okay as far as my design goes. Now, if there was a change that I wanted to make, let's take a look at this first part again. So this design, or this bend line here, is bend down at 45 degrees. So I noticed in my design history that this should actually be a 90-degree bend, not a 45-degree bend. So let's go back to Inventor. We can kind of see that here. That looks a little bit off, being a 45 degree. It should be really that 90-degree bend. So I can open up that component. And what I can do is I can take a look at that particular bend. We can edit this feature and say, okay, let's bring that back to 90. And it's going to ask me to check it out. I want to check that out from my vault so I can save that design. Okay. And now it's at that 90-degree bend. I'll check that back in. It's going to save it for me. I can give a comment. Change bend to 90 degrees. And just say OK. So now that's back into Vault with that new version of that particular assembly. And all I need to do is come back into here. We'll go ahead and just re-download that particular assembly from Vault to get the latest version of that part file. We'll go through this translation process again. We'll pull out that file, and we should see that bend information update on that particular file that we changed. We can see now it's telling us it's a 90-degree bend, which was what it should be. So at this point, I'm ready to move along in the process. Everything in the design is ready for manufacturing. I've got all my information here about the material and the parts. I'm ready to place an order. So for this next step, I'm going to go to order entry inside of my orders node in the tree. So what this allows me to do is it allows me to query all the parts that I have in the system and kind of build this order for the schedule that I want. So I can start typing in. I know that the assembly is called the PC chassis. So I've got it here. If I didn't want to type in the whole thing, or if there was a lot of things that started with PC, I can actually choose this option here for an autocomplete, and it will fill in the rest of the information here for me. So now I've just filtered on the parts that I'm interested in to order. And now I can assign things like a particular quantity, a particular due date that I want to schedule these for, a priority for that order. So if this assembly needs to jump the queue in the front of the line, I can give that a high priority, and I'm going to see that first in my nest. So I can get that process on the machine and out to the next stages in its product life cycle. I can give it a job order. So here's where we can sync back to things like ERP and MRP, driving different job orders and carrying that information throughout TruNest as well. And then we have things like material group, facility, and comments. So facility, I can actually use TruNest to integrate with multiple sites. So if I've got machines and materials on one site and another site, I can order all this stuff together and then have everything filtered down to the appropriate facilities afterwards, so that I'm maintaining that entire schedule across my company instead of just at a particular site. So go ahead and add these orders, and they go into this table down here called my active orders. So I've got that particular assembly, and like I said, we can integrate with MRP ERP systems to drive this process automatically from a schedule. I'll kind of give you a preview of that. So I'll bring up another screen, which is exactly that same order. And just at a basic level, I can do things like import a file, like a CSV, and import that directly into my order. So I've got this order that could have been driven or exported from an MRP or ERP system. I'll just go ahead and open that up. And now I've got all these different orders for, again, this PC chassis, but the job order could be different. So I've got the one that I scheduled initially, but I've also got a job for Monday, Tuesday, and Wednesday in here as well, which are have different dates associated to them. So now I've got this huge list of orders. So what I can do is I can go into my schedule order screen, and it's going to give me a bird's eye view of everything that I have in the system. So in this particular order, I've got 4 different jobs. We saw the one I placed plus Monday, Tuesday, and Wednesday. We have this particular material, so there's some parts on this aluminum material, and there's other parts on this steel material. So I've got 3 unique parts on that material and 16 pieces. And I've got 6 unique parts on this material and 28 pieces. So altogether, I've got all my parts, pieces, and my materials here, but I also have some options as far as the equipment that I want to run this on. So this material can actually be run on a laser and a water jet, and this material can be run on a laser and a plasma. So in this case, I want to run everything on the laser, so I'm going to select those 2 and push them forward in the process. In this table down below, we actually have everything that's in the system already. So this is current snapshot of what production looks like. So I've got things in different statuses. Everything is a different status within TruNest, whether it's ready to be nested, whether it's been nested and needs to be sent to the shop, whether it's been cut on the shop floor. I can see which machines it's currently being scheduled on, as well as the current amount of time and material that's currently scheduled on that machine. So I can make decisions on if I have more than one laser in my shop, which lasers to send that down to. Maybe there's already 10 nests queued up for the first one, for my trunk or Magestic, whatever it ends up being. So I might want to order for the other machine that I have in order to kind of plan out my schedule a bit better and more optimally. So go ahead and select those two. It's going to be created under group 6 and nest prefix N. So we'll go ahead and schedule that. And we'll see that show up here. So now I've got my orders went from unscheduled to scheduled. We can see the status there. We have the 2 materials and all the job information as well on those. So I'm ready with my order. Now I can come here under my nest, so I see that group 6 as well within this. And I can just go into create nests, select both of those material types, and launch the nesting. So what this is doing at this time is it's going through and it's running through various algorithms and giving me the best efficiency for the mix of parts that I have. You can see for this particular material, it's also trying multiple inventory sizes, switching between a 120 by 60 plate and a 96 by 48 plate to try to get me the best efficiency for the mix of parts that I have. So in this case, I might use some of one material size and some of the other one in order to get the most efficiency possible on this particular nest. So it's going to go through, it's on to the second material now. And again, this material has the same inventory sizes, 120 by 60, and it's going through and it's nesting all that. At this point as well, it's creating all the reports that I mentioned earlier about the nesting efficiencies, the parts that were on each plate as well. And then additionally, we run optimizations on each plate for the process and the material type that we currently nested. So in this case, it's automatically running a tabbing routine. So it's placing tabs on each shape in order to hold it to that material automatically based on a set of rules. It's also doing what we call head-down logic and sheet cutting. Head-down logic is a process where we try to go through and minimize the number of times we have to pick up and move the head by optimally moving from sheet to sheet. And then we do sheet cutting, which is a processing of the sheet itself into smaller, more manageable pieces of that skeleton to better safely remove that from the machine bed. And then after all that happens, we run our post-processor, which generates CNC code for each plate based on all those optimal processes. So we can see the results here. All of the white lines going from point to point are that head-down logic. So it's showing you some of that off-part motion that we're doing after we're cutting a shape and going to cut successive shapes without traversing over any pre-cut parts. We don't have to worry about crashing the tip of the machine head with material on the bed as well. You can go through and look at the results for this. You can see all the different colorizations for the different qualities of a laser. We have all of our etch lines for the bend lines for the machine as well. So we can kind of go through. We see these red lines. These red lines are the sheet cut operation. So it's cutting up this skeleton into smaller pieces so that I can manage it easier. And we can see some of the results that we have here. everything looks good with that. So we generated our nest. Everything looks good inside of our nest. We can take a look at things like each individual plate if we wanted to. We can take a look at the overall nesting report. So if I wanted to see information about each particular piece and each particular nest, I can see that here. It's going to give me a lot of details on each one of the plates that I have. So I can go through, I can see what properties were used, things like what's the kerf value on my machine, what is the separation that I use between parts, what is the goals for my efficiency, any grain constraints that were used, whether I can rotate parts at certain angles, as well as all the piece information, so I can see what part was on what job and which plate that it ended up being on, what grain constraints were on that particular part, whether that part was mirrored, the priority of those things. So I can see all that information within the nesting report. And if I dial down into each plate, I can go ahead and see the NC code for each plate. So I can go ahead and investigate anything that I want to about the NC code, see all the processes here, make sure everything looks okay. I also have under this group a managed nest node inside of the tree. And this is again going to give me a snapshot of all the materials and all the plates that were generated from that nesting process. We can see things like the efficiency right from here of that plate, whether we met our efficiency goal, which gives me the stage status, or whether it's rejected and I didn't meet that efficiency goal. Which allows me to do things like if I didn't meet my efficiency goal, let's see, we've got some 67% here. Maybe that's too low for me. I can do things like put the parts that were on that plate back into that scheduler queue in order for more parts of like materials to aggregate within that scheduling system and then be nested together again to hopefully gain some more efficiencies on those things. So as a final process, what I'm going to do is I'm going to send all these particular plates and NC code down to the machine tool. So I'll click that send operation. And what that's going to do is going to gather up all that information and send it down to the machine in either a folder or however it gets delivered to that particular equipment. And it's going to change my status to sent down to the machine. So this tells me that I'm, as a nester, I'm done my particular operation. Now I've got to wait for feedback from the shop to let me know that those plates have been processed. So we can also take a look, if we can pull some information up here. So if we look at some of the plates towards the end of the process, we'll actually see some of them were generated with what's called a remnant code. So some of the FTR0241, based on settings within the nesting software, if the remaining material is large enough for you to store back into inventory, we'll actually update inventory with those things. So if we go to our inventory, we can see that that STR0241 actually made it back into our inventory. It's got the updated length and width, and it's ready for me to use on the next run of material that I have. So we can track remnants through the system, use them for later in the process as well to gain efficiencies in material usage. And then lastly, one of the things that we can do from this workspace as well, we can do things like export a DXF of the nest if I wanted that geometry for some other process, or if my machine runs on a DXF file, I can directly output that as well. I can output PDF files of the nest plate as well. I can review the NC code, and I can do things like a backplot of that particular NC code. So a backplot is actually a reinterpretation of the direct NC file to give me exactly what's going to happen on the machine. So this allows me to see things like, what shape's going to be cut first, second, third, all the sequencing. It's also going to show me all the cut lines for the sheet cut, so you can see some of those there. It's also going to show me some of my lead in and lead out settings for each of the internal shapes and external shapes as well. We can investigate the information that we have here, make sure everything looks fine before we go out and run it on the machine. You can actually see some of the tabbing as well that was automatically generated on each of the parts as well. So you can see some of the tabbing that leaves the part stuck to that sheet for easier processing within that back block. So just to summarize, we went through, we brought our parts in from Vault directly within the TruNest. It had all that information associated to it. We created our order, we scheduled that order, and we created our nest, ran all of our different optimizations on that particular nest, and then sent that down to the shop. So that is a typical workflow within TruNest from day to day, and you can set this up to where you're running just in time, or you can schedule production weeks ahead of time. The system really allows you to do all that to your preference. So what I will do is I will open it up for questions.
Yeah, there's a couple of questions, Matt. We have one.
So,
we have our first question asking, does changing the status trigger a workflow event?
that's a great question. So let me just kind of pop back into TruNest. Sorry for switching around. So each one of these statuses, and I kind of mentioned them as I was going through the demonstration, do trigger some sort of event within the software. And it's really telling you as a user of the software where everything is and what process, but it's also triggering things like materials entering back into inventory. So when I did this sent process, it actually updated the inventory that I had for the remnants that needed to get back into inventory. We do that on the sent process in this case, just because at that point, the users kind of validated everything. They don't want to run any more tests. They want to send it and cut it on the shop floor. So you can really trigger things based off these statuses, which those are just one of those things. So we do have all these different workflow events within the software and do some automated tasks based on those and based on the status. That's a great question.
Okay, we got another question from Joseph. A little unclear, but I'll try to read it out. What if you have an aluminum length line that lets you cut variable sheet lengths? Would you have to create each size? Okay.
So I think what Joe's explaining here is he's got stuff that's cut to size, essentially. So instead of stock sheet sizes, like for inventory, so here I've just got some inventory 120 by 60. You can certainly run TruNest in a mode where it will drive your kind of sheet cutting line as well. So we've got some customers actually doing this. They call it a blanking system. So essentially what happens is we actually pre-nest everything within the software for them so that they know exactly what their sheet lengths need to be based on constraints like frame around each part, trims on the material, things like that. And then we run, we actually send that information to that line so they can say, okay, this particular sheet is going to be 41.25 inches. This particular sheet is going to be a 46, all that stuff, and then automatically generate those processes based on those material sizes instead of the stock sizes. That's a great question.
Okay, Joseph seemed to reply, yes, we purchase aluminum in a coil, then cut to any length off the coil, off the roll.
Yep.
Okay, we have a couple more questions. Can you explain common line cutting?
Good question. So common line cutting is a process where we're sharing geometry between two like parts. So if we go into some of the examples that I have already in the system, we'll take it and look at the same parts, but in a common line situation. So common line nesting ignores separation values between parts because we want to put those parts close enough together that they share a particular segment. So what happens during the nesting process is those parts are spaced by the kerf width of the machine tool for that material. So what that allows us to do is it allows us to cut this particular segment one time instead of having to process both segments of each individual shape. So it's a very special nesting process, and we have unique optimization routines for the tabbing as well as the head down logic and things like that for common line cutting. So you can see some of those examples here where we're sharing some of those segments between parts.
Excellent. Okay, I have another question. Can you change quantity of parts, material size, machine tool just before cutting if conditions on the shop floor change?
That's a great question. So if, for instance, you set this particular schedule up, all these nests, all these materials up, weeks in advance, or however you're running your production, and something changes. Maybe I need one more of this particular part, or maybe some of my nesting constraints change. I can actually change them underneath each nest run. So I have a list of nesting parameters, plate parameters, and part parameters within each nest run. And all this information is taken from the database of defaults within TruNest. So things like the inventory table, which I showed before, is a list of defaults that populate some of these kind of just-in-time views that we're looking for. So I can actually modify some of these defaults on the fly without, for this job, without modifying the default value. So if in this case, I really don't want this part to nest at 90 and 270 degrees, I can make that change on the fly, and I don't have to do anything else within TruNest or mess with the default value, anything like that for that information. That's a great question.
Okay, I don't think we have any more questions, but we had someone put their hand up, but I don't see a question from them. Yeah, I guess if anybody has any more questions, Scott has.
Yeah, there's a question in. If there's any more, that's
got one more.
okay.
Okay, well, we got one more question. Can TruNest ensure parts are manufacturable?
Yeah, so that's also a great question. So when I do that translation process, and then when I brought that those parts in the system, we went through, we saw some of those dialog boxes that came up during that process. And what it's doing is it's actually pre-validating those shapes for the machine tool and the process that you're using. So that colorization that I talked to before of the different laser qualities and things like that, if there was a particular piece of geometry that couldn't be manufactured, or if the shape was, say, open or not closed or not connected in any way, TruNest is going to warn the user during that process that some of the part files that they're trying to bring in are not suited for nesting or manufacturing. So that gives the end user the ability to go back to design before he creates his order, creates his nest, and does all this work, to go ahead and fix those things and then re-import those parts, just like I changed that bend line, changed that design information, and just re-imported that information directly in the TruNest.
Okay, we got one more question. If you got time, Matt, for one more.
Mm-hmm.
Okay. Can we change the kerf value for inside and outside cutting for different profiles?
Yeah, that's a great question. So on laser machines, I mentioned quality a couple times for the laser. So that quality comes with a couple different parameters. So when you're running that laser at different qualities, it's going to have different focus lengths and things like that for the power that it's cutting that material at. And that's kind of where that quality factor comes in. So as part of that quality value is the kerf value. So the kerf value is how much material is removed during that cutting process. So if you wanted to particularly flag a shape yourself, you can certainly do that in design and colorize that based on the quality that you want. Or you can set up the automated rules within TruNest to intercept that geometry and colorize it for the appropriate kerf settings or quality values that you want to implement as well. That's a great question.
I don't think we have any more questions right now, but I would recommend that if you have any further questions, that you can also send us an email. I think Matt, you might have some of that information on the screen.
Yeah.
We just got one more question. Okay. I think we can answer this one.
Sure, go ahead.
Is there any way we can make sure that the parts are nested properly as we need them? That's an interesting question.
Yeah, so again, I'll kind of answer that question with this slide as well. So in that case, I'm sure that a lot of customers have different ways that they like to see parts nested. Some nest for efficiency, some nest for quality and process. So there's a lot of different ways people want to optimize their workflows. So the way you would make sure that your parts are nested appropriately is you want to understand which, how you're optimizing your nesting process. And then you can validate all that information with the tools within TruNest. So just from that graphical view, you can look at the parts, make sure that all the parts are spaced correctly based on your separation parameters. You can take a look at all the optimizations, all those things within the nest that are automatically generated, and just validate those, on a per plate basis. So I will say a lot of customers at first, what happens is they go through this validation process, but then they gain kind of a trust factor with TruNest and start to understand that TruNest is doing things repeatedly and over again, and they don't need to necessarily check on everything every time, more so on things that are new to the system, just to make sure and validate those new parts for manufacturing.
Okay.
So if I didn't answer that question correctly, we have these resources here. So for Rob, his email's there as well. You can go to these links for both SolidCAD and Magestic's websites. Ask us any of the questions that you have, or ask us directly at either one of our emails as well.
Great job, Matt. Thank you very much.
No problem. Thank you, Rob.